Good afternoon. I am presenting our study on leading AI safety in military education, specifically, how institutions can govern disinformation risks that emerge when generative AI enters professional military training. This is joint work with Andrii Hupalo from the Center for Military and Strategic Studies of the National Defense University of Ukraine. The study draws on Ukraine's wartime experience, where the cost of a decision error in training translates directly into lives, which makes AI safety in this domain not an abstract concern, but an operational one. The starting point is a widening gap between adoption and governance. Generative AI is already inside military classrooms for drafting, analysis, self-study, and much of this use happens outside institutional control. The stakes are specific to this domain. An officer trained on distorted information makes distorted decisions. And the trend line is not reassuring. EU versus disinfo monitoring shows the share of false information in AI chatbot responses roughly doubled, from 18% in 2024 to 35% in 2025. Ukraine's military universities, operating under active information warfare, give us an empirical setting where these risks are observable, rather than hypothetical. Our own bibliometric analysis of 266 Scopus-indexed publications shows why governance lags behind. Half of the field, 50.8%, studies technical capabilities. Only 6.4% addresses ethics and safety. The literature tells institutions what AI can do, but not how to lead its safe adoption. That defines our research question. How should military education institutions govern AI-related disinformation risks, and which countermeasures deserve priority, given limited resources and wartime constraints? The design combines 5 methods, each feeding the next. Bibliometric analysis maps the field and exposes the technology bias. PLS structural equation modeling tests relationships between adoption factors and risk perceptions. An expert panel of 12 defense education specialists rated vulnerabilities and countermeasures on 1 to 5 scales: criticality, feasibility, and effectiveness. The SACRAD framework was adapted as the institutional governance architecture. Finally, Monte Carlo simulation extends the expert point estimates into probabilistic space, letting us compare implementation scenarios with confidence intervals, rather than single numbers. The expert panel structured the risk space into 4 vulnerabilities. V1, information leakage, sensitive material entering commercial platforms. V2, content manipulation, distorted or fabricated material finding its way into training content. V3, critical thinking degradation, the slow erosion of independent judgment when cadets outsource reasoning to a model. And V4, social engineering, AI-enabled manipulation aimed at personnel. Note the mix V1, V2, and V4 are operational risks with immediate manifestation, while V3 is cognitive and cumulative. This distinction will matter when we look at what countermeasures can, and cannot, achieve. Countermeasures were mapped onto a feasibility and effectiveness matrix. 2 measures stand out as immediately deployable: training scenarios and verification checklists, both rated high on feasibility and effectiveness. Competency assessment sits in the middle. The surprise is CM1, full SACRAD framework integration. Experts gave it the lowest feasibility, 3.08, and the lowest effectiveness, 3.17, placing it in the reconsider quadrant. The panel also confirmed that information security threats outrank cognitive threats in perceived criticality, yet the most implementable measures address the operational side, not the cognitive one. That asymmetry motivated the simulation stage. SACRAD is the governance backbone of the study. Its function is to move AI safety from individual vigilance, hoping every cadet double-checks a chatbot, to institutional responsibility. 3 layers. The policy layer sets binding rules for permitted AI use, data handling, and source verification. The pedagogical layer embeds training scenarios and verification checklists into curricula, precisely the 2 countermeasures experts rated most deployable. The operational layer adds competency assessment and continuous monitoring, which keeps the governance adaptive, instead of declarative. The question the experts left open was quantitative. How much risk reduction does each configuration actually buy? That is what the simulation answers. The simulation translates expert scores into distributions. Each risk component, criticality, probability, severity, is modeled as a truncated normal distribution centered on the panel means, and their product gives the risk priority index for every vulnerability. Aggregating across the 4 vulnerabilities produces the composite disinformation risk index, our headline metric. We compare 4 scenarios: a baseline with no countermeasures, partial implementation limited to the 2 most feasible measures, training scenarios and checklists, full SACRAD deployment, and an escalation scenario, where threat intensity grows in line with the doubling of chatbot disinformation actually observed between 2024 and 2025. Here is what governance buys, in numbers. The baseline disinformation risk index is 39.5. Implementing only the 2 most feasible measures cuts it by 41.2% to 23.2. Full SACRAD implementation brings it down to 13.4, a 66% reduction, and, just as important, it compresses volatility. The standard deviation drops from 8.6 to 3.0, making the risk environment more predictable. The escalation scenario is the warning. Without action, and with threats growing at the observed pace, the index rises to 59.6. The distance from baseline to escalation exceeds the distance from baseline to partial implementation. The cost of waiting is larger than the gain from acting partially. The aggregate hides a structural pattern. Operational risks respond readily. Social engineering shows the strongest effect, an 82% reduction. Its risk index falls from 45.2 to 8.3 because it is covered by both top-rated countermeasures. Content manipulation drops 70%, information leakage, 62%, the latter limited, because technical protections such as restricting commercial platforms lie beyond educational interventions. The outlier is critical thinking degradation. Under 40% checklists and scenarios cannot rebuild reasoning habits. The cognitive dimension demands a long-term pedagogical strategy running alongside the immediate measures, and this is the central governance implication. 4 implications for leaders of military education institutions. First, act partially now, rather than fully later. 2 feasible measures already remove 41% of composite risk, without institutional overhaul. Second, prevention beats reaction. The escalation gap of plus 20 index points exceeds the 16-point gain from partial implementation, so waiting is the costliest option on the table. Third, pair quick operational wins with slow pedagogy, because the cognitive vulnerability will not yield to checklists. Fourth, govern volatility. Not only the mean, full SACRAD makes the risk environment predictable, and for institutions planning under wartime uncertainty, predictability is itself an asset. 3 limitations deserve mention. The simulation is only as good as its inputs. It models uncertainty in expert judgments, but cannot correct biases shared across the panel. Countermeasure effects are assumed independent and additive, while real-world interactions may be synergistic or diminishing. And the single-country wartime setting bounds generalization, even as it provides unique evidence. Next steps follow directly: longitudinal validation of the modeled risk reduction percentages in institutions that implement the framework, extension of the expert panel across NATO member states for comparative calibration, and the full manuscript is prepared for submission to a Scopus-indexed journal. To conclude, leading AI safety in military education is a governance choice, not a technical afterthought. Our evidence shows that partial implementation of feasible measures cuts disinformation risk by 41%, full institutional governance by 66%, while inaction under escalating threats raises it by half. The instruments, training scenarios, verification checklists, competency assessment, policy integration are already within institutional control. What is required is the decision to lead. Thank you for your attention. I welcome your questions.